Hi, welcome back to our third video for 3.2 exponential decay connecting to negative exponents. In this video, we're just going to review some exponent rules, and then we're going to go ahead and learn a couple new ones and then apply them. So our first exponent rule, it is called the product rule. When multiplying powers of the same base, just add the exponents. So if you're multiplying two powers together and they have the same base, you can just add the exponents. Okay, there's an example of that. So x to the exponent a, that's the first power, times x to the exponent b, that's the second power. Well, because they both have the base x, they both have the same base, that means we can just add the exponents. Okay, so they have the same base x, and we just add the exponents together, okay, to get this here. Okay, the next rule called the quotient rule. So quotient always refers to dividing. So if we're dividing powers of the same base, just subtract the exponents. So x to the exponent a divided by x to the exponent b. Well, because they both have the same base x, we subtract the exponents, so we get x to the a minus b. The power rule. So the power rule is whenever we have a power raised to an exponent. So kind of like a power of a power. So when a power is raised to an exponent, just multiply the exponents. So if we have the power x to the exponent a raised to the exponent b, then we could just multiply a and b together. So we would get x to the exponent ab. Our last rule, which we just learned a few days ago, is the zero exponent rule. So when a base b is raised to exponent 0, the power is equal to 1. Okay, so anything raised to the exponent 0 is 1, except for 0. 0 to the 0 is not 1. Okay, there's one other exception to all these rules too that were mentioned, and that is that x is not 0 for those as well. Okay, all right, I think we can go ahead and learn the next rule now. So go to the next slide here. So there's a new rule that we're going to learn for exponents, and it's when we have negative exponents. So a power with a negative exponent can be expressed using a positive exponent. So if we have a negative exponent, we can actually do something and rewrite it as a positive exponent. So the negative exponent rule states that if you have something raised to a negative exponent, like we do here, that you can simply rewrite it as a positive exponent, except you have to place it in the denominator. Okay, so you can place it in the denominator and then give it a positive exponent. So there are some restrictions. So b can be anything except 0. And the exponent can basically only be a natural number. So like counting numbers. So whole, like numbers 0, 1, 2, 3, and 4. Okay. All right, so our first example. So let's just practice a few of these. 3 to the exponent negative 2. So if we apply the negative exponent rule, we can just rewrite this as 1 over 3 to the 2. Okay? Because the rule says b to the negative n is just 1 over b to the n. Okay? So we can also evaluate 3 squared. We know that would just be 1 over 9, because 3 squared is 9. Okay, and that's it for the first one. So 6 to the negative 2 times 6 to the 3. So I would like to apply the product rule. Which states that when we're multiplying powers with the same base, notice these both have a base of 6, that I can rewrite it and just add the exponents. So negative 2 plus 3, that's going to give me 6 to the 1. Okay. And 6 to the exponent 1, well, that's just 6. So these first two are done. Okay, I like to always state the exponent rules that I'm doing. So even for part A, to go from here to here, we just applied the negative exponent rule. So this will be good for our notes to keep these. That way when we look back for studying, we'll know what rules we're applying. So apply the negative exponent rule. Okay, we'll do a few more examples. So negative 2 to the exponent negative 4 plus 4 to the negative 2. Okay, I would like to rewrite this with a positive exponent. So I got to move that to the denominator and write it as a positive exponent. Same with the next one, 4 to the exponent negative 2. It's going to be 1 over 4 squared. So that's the negative exponent rule. And negative 2 to the exponent 4, well, that's going to be a positive 16. Because negative 2 times negative 2 is 4, times negative 2 is 8, times another negative 2, positive 16. Okay. One thing I also do, just to remind you guys, when you're doing a question like this, you can always break it up into 2 powers. Okay. You can always do the reverse, and then you can say, oh yeah, this is just 4 times 4, 16. So it's a quick way to kind of do some of these, to evaluate some of these powers. Okay, so going back to this example, we have 1 over 16 plus 1 over 4 squared. 4 squared is also 16. So we have a common denominator. We can just add everything. We get 1 over 8. Because 2 over 16 reduces to 1 over 8. Okay, this next one here. So we have the negative exponents. So I notice this is also like a power of a power. So I can apply the power rule first. So we'll say here for that part, apply the power rule. Okay, that means when you have a power raised to an exponent, we can multiply the exponents. So we would get 4 to the negative 2 times negative 3. Okay, and then we're supposed to divide that by 4 to the exponent 8. So negative 2 times negative 3, that's a positive 6. So we have 4 to the 6 divided by 4 to the 8. So now I should apply the quotient rule. Okay, I can do that because we have the same base. The base is 4 for both of those. I can just subtract the exponents. So we're going to have 4 to the 6 minus 8, which gives us 4 to the negative 2. Okay, and then I got to apply the exponent rule one more time, the negative exponent rule. So I get 1 over 4 squared, which is just equal to 1 over 16. Okay, now we're going to move on to, a few more examples, and then we're going to move on to another exponent rule. Okay, so simplify these expressions that have negative exponents. So a little bit more practice for us. So the last example we were evaluating, now we're actually working with more algebraic expressions. So I could apply the power rule to this because they all have the same base x. I could just add their exponents together. So negative 2 plus a negative 3 plus 4. So negative 2 minus 3 plus 4, that's going to be negative 5 plus 4, that'll be negative 1. Then I can apply the negative exponent rule. Oops. Negative exponent rule. And I'll have 1 over x to the 1, right? So I move it in the denominator and make the exponent positive. So 1 over x to the 1, well, that's just 1 over x. Okay, you don't even need to write that exponent 1 in. Okay. All right, the next one. So this one's a little bit different. I can't multiply a squared times the b negative 2. Like, I don't know those values. But I notice I have like terms, like in the numerator and the denominator. I have powers at the same base, so this means I should apply the quotient rule. Okay, you might say, well, Mr. A, we have negative exponents. Shouldn't we like do the negative exponent rule? You could, but I would rather just do the quotient rule because maybe those exponents might work out to be a positive value. So let's do this first. So for my a's, I have a squared divided by a to the negative 1. So that just means a to the 2 minus a negative 1. Okay, that's the quotient rule. So I'm basically just looking at this part right here. Those powers have the same base and we're dividing them, so we just subtract the exponent. So it'll be a to the exponent 2 minus a negative 1. It's actually going to be 2 plus 1. It'll give us 3 in the next line. Okay, now for the next part, for the b's, we have b to the negative 2 minus 2, because those also have the same base, so we just subtract the exponents. So this works out to a 2 plus 1 is going to be 3. And for b, we have negative 2 minus 2. That's going to be negative 4. Okay, now I can apply the negative exponent rule. We have a cubed over b to the 4.